Chapter 4. Sound and light waves. Students could learn about the properties of sound and light waves, how they are produced, and how they can be measured. Sound waves. Sound waves are longitudinal waves that require a medium, such as air or water, to travel through. The properties of sound waves include frequency, the number of sound waves that pass a point in 1 second, measured in Hz Hc. It determines the pitch of the sound, with higher frequencies producing higher-pitched sounds. Amplitude, the height of the sound wave, measured in decibels, dB. It determines the loudness of the sound, with higher amplitudes producing louder sounds. Wavelength, the distance between two consecutive points on a sound wave that are in phase, measured in meters, m. It determines the size of the sound wave, with longer wavelengths producing lower-pitched sounds. Sound waves are produced by vibrations of an object, such as a vocal cord or a guitar string. They can be measured using a device called a microphone, which converts the sound wave into an electrical signal that can be recorded and analyzed. Light waves. Light waves are transverse waves that do not require a medium to travel through. The properties of light waves include frequency, the number of light waves that pass a point in 1 second, measured in Hz Hc. It determines the color of the light, with higher frequencies producing higher energy light such as ultraviolet and X-rays. Amplitude, the height of the light wave, measured in units such as watts or lumens. It determines the brightness of the light, with higher amplitudes producing brighter light. Wavelength, the distance between two consecutive points on a light wave that are in phase, measured in meters, m. It determines the color of the light, with longer wavelengths producing lower energy light such as red and orange. Light waves are produced by the acceleration of charged particles, such as electrons in an atom. They can be measured using a device called a spectrometer, which separates light into its component wavelengths and measures the intensity of each wavelength. In summary, sound waves are longitudinal waves that require a medium to travel through, while light waves are transverse waves that do not require a medium. Both types of waves can be described by their frequency, amplitude, and wavelength, and are produced by the vibrations of objects or the acceleration of charged particles. They can be measured using various devices such as microphones and spectrometers.